The promoter is the section of wrapped black pipe cleaner, and it is where RNA polymerase attaches with the help of transcription factors, the green balls of pipe cleaner. Together, along with the Tata box of yellow and orange nucleotides, they make up the transcription initiation complex.
We have taken away the non-template strand and left the template strand. The start codon is AUG. A stop codon signals the end of transcription, eventually. In bacteria, polymerase stops transcription and the mRNA can be translated simultaneously. In eukaryotes, however, RNA polymerase II transcribes the poly A signal sequence. The RNA transcript is released 20 to 35 nucleotides past the poly A tail.
For RNA splicing, the non-coding introns are cut out from the exons in the RNA, represented by a brown pipe cleaner here. It starts with the proteins called SNRPs gathering around the ends and calling for a larger protein called a spliceosome to be formed. The intron ends are brought together and cut individually, while the spliceosome combines the exon ends to make the final product, the edited RNA. Before it can leave the nucleus, a guanine nucleotide cap must be added to the 5' end and a poly A adenine tail must be added as well.
Outside in the nucleus, a small subunit and a large subunit of a ribosome meet up with mRNA to start coding for the polypeptide chain. The tRNA then meets up and goes into what is called the A site of the large subunit. This carries the start anticodon. After the tRNA codes for what it needs to code for, it then moves to what's called the P site of the large subunit. This is when the tRNA carries the growing polypeptide chain before it moves into the E site, which is the exit site. This whole time, the only things that are moving is the tRNA coming in the ribosome moving along the mRNA. The mRNA never moves position this whole time, and this process is powered by GTP hydrolysis.
Nation occurs when a stop codon in mRNA reaches the A site of the ribosome. A site accepts a protein called a release factor. The release factor causes addition of a water molecule instead of an amino acid. This reaction releases a polypeptide and the translation assembly then comes apart.